EIGRP, which stands for Enhanced Interior Gateway Routing Protocol, is a routing protocol used in computer networks. It helps routers share information about the best paths for sending data within a network. Here's a simple explanation of EIGRP. 1. Routing Protocol. EIGRP is a type of routing protocol. Routing is like a roadmap for data to travel from one place, computer or device, to another on a network. 2. Enhanced version. It's called enhanced because it's an improved and more advanced version of an earlier routing protocol. 3. Interior gateway. EIGRP works within a single network, often a company's internal network. It's used to figure out the best way for data to travel within that network. 4. Gateway. A gateway is like a door or entrance. In networking, it's a point where data enters or leaves a network. EIGRP helps routers, which are like traffic directors on the network, find the best gateways for sending data. 5. Path selection. EIGRP helps routers decide the most efficient paths for data. Imagine you have multiple routes to reach a destination. EIGRP helps routers choose the fastest or most reliable one. 6. Metric. EIGRP uses a formula to calculate a metric for each route. This metric is like a score that helps routers compare and choose the best path. Factors like speed and reliability of connections contribute to the metric. 7. Automatic updates. EIGRP routers regularly talk to each other, sharing information about the network. If something changes, like a new connection or a broken link, routers automatically update each other so they always know the best routes. 8. Support for different network sizes. EIGRP is designed to work well in small or large networks. Whether it's a small office or a big corporation, EIGRP can adapt to the size and complexity of the network. 9. Reduced network traffic. EIGRP is efficient in managing network updates. It only sends updates when there's a change in the network, reducing unnecessary traffic and making the network operate more smoothly. In essence, EIGRP helps routers in a network communicate with each other to make smart decisions about how data should travel, ensuring that information gets to its destination quickly and efficiently.